Today we're trying to construct a triangle from the intercepts of a particular quadratic expression, then find the measure of an angle in that triangle. So what we're going to do is just go ahead and sketch the triangle first and then proceed. This is very straightforward here. This expression factors very nicely. And so two of the intercepts would be x equals to 13 and x equals negative 6, right? So those would form the vertices associated with A and C, the points A and C, all right? Now, as far as the other one, that's also very easy. You would get y. Remember, another name for the y-axis is x equals 0, so you can write down y is equal to 0 squared minus 7 times 0, minus 78. And of course, that's equal to negative 78. That's the easiest intercept to find in a quadratic, right? Just take the constant term. Okay, so these are the vertices of our three triangles. That is, we could call this one A and C if you wanted to. Here, and we could call this one B, right? And we're supposed to find the measure of the angle where B's in the middle of the angle, okay? So let's carry on. Now, I've already drawn the picture for you here, and you can see what I've done right here. This is this distance is 6. This distance is certainly 78. And the magnitude doesn't make any difference here. You know that it's going to be acute angle, so we'll deal with positive values here. So notice that tangent of the measure, and I'll write it like this if you want to, a tangent, and I call it the measure of angle B. That's another way to write it rather than the more cumbersome ABC. ABC is good notation. It's just I don't have much room here, so we'll write it like this. The tangent of the measure of angle B, all right, like that. And we can already see what everything is equal to based on this picture over here. See, alpha plus beta is equal to this, right? Alpha plus beta is equal to the measure of angle B. So that's why I wrote it down just like this. And then the rest of this is just reading directly from the diagram. You would get 6 over 78 is the tangent of alpha. You know, remember, tangent's just defined to be the length of the opposite side over the length of the adjacent side, which is exactly what we got right here. Here's alpha, here's angle alpha right here. Tangent of alpha is the length of the opposite side over the adjacent side. And similarly, we get 13 over 78 for the tangent of theta. 13 over 78. And you know, this trig identity is not hard to prove just from this addition formulas for sine and cosine. So let's go 1 minus the product. Now this looks like, oh no, we got to, multiply 78 times itself, but you really don't here. Usually a nice problem, if you do it right, the arithmetic is kind of minimized. So let's see what we get here. That's 19 over 78. When you add the two numerators, you already have a built-in common denominator there, right? Okay. And then here we have 1 minus 78 over 78 squared. Okay, folks, and right here, this would be 19 over 78 divided by, this will just be 1 minus 78 over 78, which is 77 over 78. I hope I'm staying on the screen for you. It looks like I am. Right, folks? And then, so you would invert and multiply here, and you would get 19 over 77. So the final answer here. So that's the tangent of the angle. We're not supposed to find the angle. You could do that with an inverse trig function if you wanted to. Anyway, that's the solution, folks, 19/77. And this was similar to an AMC problem done, I guess, back in 2022, problem number 14. But anyway, this is equal to 19/77. Okay, thanks for viewing.